Any questions? Number 5? Sure. Go to the end of my pages. Oh, that's a good one. Yeah, number 5, it looks goofy, but as soon as you see it, you're like, oh, okay, I get it. So you 90 subtract 22 over 28 minus 11. Okay, here's the goofy thing. You think you should probably divide first, but unfortunately, you have something all on top that can be combined together and something all on bottom that can be combined. And being that the fraction bar, aka division bar, is the same, you're going to kind of treat like this is in parentheses and this in parentheses. So 90 subtract 22 is 68. And then 28 subtract 11 is 17. Did anyone figure out that 17 goes into 68? 4 whole times. So this would result as an answer of 4. Cool. Yeah, this totally reduces. 17 goes in itself, 17 goes in there 4 times. So that's the math that took place. Does that help you out on that one? Yeah, that's kind of a goofier one. Anything else off the homework you'd like to take a look at? Cool. So let's take some notes. So this should be in your notebook. I think it says inverse operations or SLE number 3. I don't remember what it says at the top. If you didn't have the book yet, you can just write this down or just chill and watch it. I think the first thing on there is inverse operations is the first thing on in your book. Okay, so in math they have rules, and there are things that are inverse operations, meaning it's an operation that would undo something. So addition and subtraction are inverse operations. So in order to undo something, if it was added, you would have to subtract it. If you had it subtracted, you would have to add it. And what we're going to say is we're going to do it to both sides of the equal signs eventually. And then multiplication and division are also inverse operations. Now, one thing you have to realize is division a lot of times might be written as a fraction. So 4 divided by 3 is the same thing as 4 over 3. These mean the same thing. And that kind of goes into play when I refer back to elementary school often. Division was something that wasn't your first favorite as far as the 4 operations. And then right after division, they start offering fractions. Okay? Now, fractions are division. So if you didn't like division, guess what else you didn't like? Fractions. Because it was the same thing, but your elementary school teacher didn't tell you that because they might not have known it. And I always had a hard time with fractions because you might have had this type of thing told to you, and a lot of times I was the kid that the teacher would always, make sure that they were saying my name because I'd be like staring at something, ooh, there's a bug on the floor. Oh, cool. Ooh, there's a spider. I hope it bites somebody. And I'd watch it. I mean, I was always off task. That was just me. So I remember as far as fractions go, I would have a teacher say, Chris, you have 2/3 of one pizza left, and you have 5/6 of another pizza left. What do you got? And I'd be, lunch! No, Chris, that's not the answer they were looking for. I always thought, hey, you're talking about pizza. That's just mean and cruel to do because I like pizza. And now I'm gluten-free, and I found some really good gluten-free options. Don't feel bad for me. I'm gluten-free. I feel amazing being gluten-free. I already felt great not being gluten-free, but even feel better not having any of the gluten in my world. Flour. Yeah.
Is being gluten-free a choice? I'm sorry.
I made it as a choice. Yes, absolutely. Yeah, you won't offend me by asking. No, my wife, she is a college professor at CU, teaches chemistry. She reads way more than I ever will. She'll read more in a day than I'll read in a year. So she reads all this research. She goes, hey, I found this great stuff about this not being on gluten. So let's try it. Well, here's where my problem is with gluten. I'd see a jelly donut. Oh, yeah, baby. I'm eating that jelly donut. First 2 weeks of not having gluten, it was like, oh, I crave it so much. After that, it's like, walk by that jelly donut going, I bet it tastes good, but I'm not in. So I know. I didn't like drop weight or anything. I just feel better than I did. I don't know. What you all find is you all are young and in a wonderful time of life of being youth. As you get older, you start monitoring more and more what you ingest, and because you want to still feel good. So there's this kind of thing. I'm going to show you something kind of fun with a fraction that's going to make you go from disliking adding and subtraction, adding and subtracting fractions to liking it. Now I'll show this, but I'll show this numerous times throughout the course.
How do we get from fractions to gluten?
Because my mind works that way.
No, but genuinely, how did we get?
I don't know. Pizza, because I was talking pizza. So this would have been like that pizza question I just kind of presented, maybe not the exact one, but you have 2/3 of one pizza and 5/7 of another. Of course, I'm thinking I got lunch. We all know that when we add or subtract fractions, we need to get a common denominator, which didn't become our best friend. I'm going to show you something that you might not have ever seen, and it's the greatest thing ever, and I wish they would have taught it all to you originally, and your anxiety of fractions would have been gone. Add, subtract fractions. If you do it the Stirrup way, 2 times 7 is? 14. Plus sign, because there's a plus right there. Still with me? 5 times 3 is? 15. And then 3 times 7? 21. Add the top, so I get 29 over 21. Check to see if it reduces. It does not. Keep it as a improper fraction, meaning the top number is bigger than the bottom. That's as simple as you can get with adding and subtracting fractions. A lot of times, mathematical books call it the butterfly method. I call it the Stirrup Method. Okay? Have any of you ever seen that before? Cool. A couple of you? Yeah. I guarantee if they would have taught you that with fractions originally, the anxiety would go from like 70% of the class afraid of fractions to like 20%. I mean, it would have a significant drop. But so inverse operations. So inverse operations. In order to use an inverse operation, a lot of times we need to solve for a variable. A variable is a letter or a symbol used in math to represent an unknown. As you advance further and further in math, the unknowns could be multiple. You can have many unknowns in a problem, and you try and solve what the problem would be. These are called one-step equations because basically right now there is one mathematical operation that has to take place in order to get the variable by itself. Now there's a number of ways that this can be gone through. One way I like to show starting out is just kind of draw where your equal sign is, just a vertical line. Okay, now you don't have to do this, but this basically shows you by doing this that you have a left and a right side of your equal sign. Okay? So, first problem, I have x added to 5. Well, what's the inverse operation of addition? Subtraction. So I'm going to subtract 5 from both sides. Those cancel, so I wind up getting x equals 7. Okay? Pretty simple. And you've been doing this for a long, long time. I mean, perhaps in elementary school, you had blank plus 5 equals 12. Hey, what do you have to add to 5 to get to 12? And it would be 7. Okay, so this is not a new concept. You've seen it a number of times in years past. And again, in elementary school, they usually have a blank plus or a blank minus equals a number. So you just kind of have to analyze it a little bit and go through it. Then when you get further in math, you start putting a variable, aka a letter or a symbol, in place. Problem number 2. Anyone want to take a shot what we should do to both sides? Go ahead.
Add 11 to each side.
Yeah, add 11 to both sides. That way those cancel, so I'm left with x, and x equals 29. Seem okay? So that's for adding and subtracting them. Number 3, how is 2 and a? How would 2 and a be held together? What do you think? They're being multiplied together. So what is the inverse of multiplication? Division. Ta-da. So if I divide each side by 2, those cancel. So I get a is equal to 22 over 2, I think is 11. That seems pretty straightforward. 6 and m, again, are being held together by multiplications. How would I undo getting m by itself? Go ahead. Divide each side by 6. And then you should check, if you do have a fraction, see if you can reduce it. Well, I think I have 9 over 6. And 9 over 6, I think 3 goes into both. 3 goes into 9 3 times, and 3 goes into 6 twice. And yes, we do want you to reduce fractions, but we don't want you to convert improper fractions into mixed numbers. Mixed numbers are a big no-no in math. I wish they didn't teach them. It is a confusing method because a lot of times when you write a mixed number, let's face it, our penmanship isn't always the best. So then you might say, oh, 3 1/2 is the same thing as 1 1/2, but you make the 1 too small, so that looks like you have 12 over 2 or something. And so, or 11 over 2. So you just have to be cautious with it. On number 5, it is a one-step equation, but there's a step that you probably should do first. And please tell me what you think I just did with that step. Go ahead. Yeah, you had a negative over negative, and in between the negatives might have been a parenthesis, but it wasn't a number, another number or a variable, so you can just turn it to positive. So if we do the inverse, I'm going to subtract 4 from both sides. Those cancel, so I get z is equal to, that's supposed to be a 4, but my penmanship is getting worse and worse. I'd like to blame the computer, but I have bad penmanship. Hey, number 6, x over 2. X over 2 is a division. It's a fraction, but it's also division. So how would I undo division on number 6? Multiply. I'm going to multiply both sides by 2. Those would cancel each other out, and then I have negative 3 times 2, which is negative 6. And that's how we do it. Any questions about this so far? And yes, we'll get to a point where we're doing more and more and more steps. So, but this is just taking a baby step, saying, hey, we're doing a one mathematical operation in order to get the variable alone. Now, let's kind of, before we start getting into the when are we ever going to have to use this in life, which is totally always a valid question. A lot of times that comes in as we get to multiple steps. And that's usually the decipher of, Mr. Stirrup, I'm really confused, but I want to try and grandstand the whole class and show that we don't have to use this in life. Which is fine. This is a thought process. Okay, there is a mathematical undoing. You're dealing with a puzzle, which is the math problem, in order to solve it. And that's kind of an important thing to think about. Now, places where inverse operations take place. I know there's some really cool features on phones. Some of you have the phone that you can aim it at your face and it'll open up, right? Now, that's a pretty basic algorithm. Basically what it's doing is the geometry of your face. It might have like 4 or 5 indicating points that it looks at your face, and it goes into the iteration, and it does the inverse operation to open the lock to get into your phone. There are certainly some facial recognition programs which are a lot more intense than what just the iPhone has. Now, realize this, the iPhone itself is pretty amazing, or whatever phone that you're using that has facial recognition. Some of you might have the phone that you're able to put one of your fingerprints over the button and it reads that. And usually it takes 5 or 6 points off of your fingerprint and it then unlocks it. Now, is it an ideal situation? It depends how many points of reference that you use. If they just said, hey, we just want to know the distance between your pupils and that's what we're going to base on how we open your phone, then the probability you find somebody that has the same distance between their pupils out of like however many billion people are on the planet, it probably would open pretty nicely. So I'd imagine the iPhone would probably go, the distance between your pupils to your nose is also a distance, and then to the bottom of your lip. That might be what they're putting in place. There's other things that the facial recognition will do as other geometries that are certain measurements is what it's doing. Yeah?
My sister's face opened my mom's phone,
Yeah?
but like she doesn't have her face in my mom's phone.
Huh. That might be just a default in it, or the measurements are close enough, you know, because let's face it, do we want people to be able to get on our phone? Probably not. But is it like government secrets in there? Well, I hope not. But I imagine like if you were doing a facial recognition program that is recognizing your face to get into a high security environment, I imagine they're going to take a lot more numbers and it's going to run through the iteration to say, yes, this works, or no, it doesn't. And obviously you can tell if your fingerprint thing doesn't work, if your fingerprint's not on it the right way, or you use a different finger. It doesn't recognize it because I don't know about yours, but mine only let me put one of my fingerprints in. It's my first index finger. So hopefully I don't lose it because my left index finger is slightly different than my right. Okay. And then the other one is you actually have to plug in, a certain numerical code or goes with a word, and that also opens it. So those are all inverse operations that do take place on your phone. Okay, the inverse operation, your phone is locked now, you show it, it works. Some of you, your parents might have cars where as long as their phone or their key fob is on or is close enough to the car, they can open the car and even start it. Okay, my car now doesn't have a place to even insert a key. You just have to I have to put my foot on the brake and push the button, and as long as that little thing that looks like a key is close enough to the car itself will be ready to drive. So that's kind of a cool thing. So I got this summer, we had no intention on buying one, but I was on summer break and I knew that our next car, I wanted to have an electric car, and so I went and drove a couple of them. And my wife controls all the money in my family, which is a good thing because I'd spend it. So we went through and we found a Nissan Leaf. We got the S Plus, so the bigger motor with the more batteries, so I can go about 280 miles on a charge. So we're sitting there and we're hearing all the stuff, and I look over at my wife and she's reaching into her purse, and I'm thinking she's getting her sunglasses because we're ready to go, and she gets out the checkbook and says, okay, what's the out the door price? And she wrote the check to buy our car. I'm like, sweet. And I got the car. Yay! So it's been fun. I've enjoyed it. It's I don't know, I'm sure most of you have ridden an electric car, but boy, you turn off some of the eco modes, they become kind of fast. Not that I'm out drag racing or anything like that, but
I mean, you could be.
I could be, but I'm 50. I kind of look like a dork if I'm out there racing people now. Yeah, I just try to get out of the way of people now. I had the point in my life where being the fastest out there was so important to me. Now I'm just living life. I'm enjoying it. We do get into a thing with word problems, and word problems offer a different type of anxiety. And really the best way to go through a word problem is you never have your writing utensil out in your hand to try and decipher what it's saying. The very first thing you should do when you come to a word problem is you don't have your writing utensil in your hand, but you just read it. So first thing that says, and we make up arbitrary names. It doesn't matter what names we're using. But this says, Jess got 5 more snaps today than yesterday. I think this is referring to Snapchat, I think. I don't know. I'm not cool enough to know this. Somebody way cooler in my department, and my team decided, hey, Snapchat's the one we're going to captivate our audience. If today she got 58 snaps, how many did she get yesterday? Okay, so one, if you don't know what Snapchat is, you would not really decipher what the heck this problem's asking for. So one, do you understand what the problem is saying? Okay, I mean, a lot of times like snaps, what are they doing this? No, they're probably referring to the social media. So Jess got 5 more snaps today than yesterday. If today she got 58 snaps, how many did she get yesterday? So basically now we can kind of go through this a number of ways. We can say, okay, we're talking about 2 different days, one after the next. It doesn't matter if it's Tuesday, Wednesday, Thursday. It doesn't matter what 2 days. But it says Jess got 5 more snaps today. So 5 more snaps today than she got yesterday. If today she got 58 snaps, I'm going to change that. If today she got a total of 58 snaps, how many did she get yesterday? Okay, so hang on. Let's see if we have this right. So I like the 5, and I like it equals 58 because we have a total and we have a certain that's more than something else. So Jess got 5 more snaps today than yesterday. If today she got 58 snaps, how many did she get yesterday? So let's call this one yesterday, which I guess as far as where we are right now in school. Today is Monday, so yesterday would be Sunday. So we're going to call this Y for yesterday. Okay, Jess got 5 more snaps yesterday. Jess got 5 more snaps today than yesterday. If today she got 58 snaps, how many did she get yesterday? If today she got 58, she had 5 more snaps today than yesterday. Oops, I don't mean that for that to happen. Go away. What do you think? Should we add or subtract, multiply or divide? Go ahead. Yeah, if yesterday was this, if I took yesterday's amount and subtracted 5 from it, I would know what we had. So in order to solve this, again, we can do our little highlight line. I could add 5 to both sides. Ooh, now I think we made a mistake. What do you think? Did we answer the question appropriately? Yesterday, Jess got 5 more snaps today than yesterday. So yesterday we called Y. Agreed? Uh-oh. What did we do wrong? Yeah, so I think there might have been a slight error. So we made this the wrong sign. I'm going to make this a plus, which then in place I'm going to change this to a subtraction, which then I have 58 subtract. There's a subtraction sign there. So it looks like 53. So there's 53 snaps. Now, notice, did I go and erase anything? No. There's no reason to go erase things in math. Okay? You're showing a progressive thought process that takes place with math, which is kind of cool. Okay? So if you make a mistake, if you go back and you look going, oh, I made the wrong sign, don't think that you have to go and erase everything. Don't be that kid, during the test that decides to erase and your eraser nub is like almost to the metal. And so you get down to the bottom and you go scratch with the metal across the paper. Yeah, you know the feeling? Yeah, I don't like that. I'm not a big fan of it. But this showed, hey, we made an error. An error is okay. We realized our error and we corrected it. Okay? I can see a lot of thought process in that kind of thing. Now, question is for you, are you able to do these sometimes in your head? The answer is yes. So how much work should I show? The amount of work that you should show, if it just said, hey, make an equation, obviously we're looking for an equation. Okay, that would probably be counting us some points. And then the solution would count us some points. But as long as you have the equation and the answer, if you could do it in your head, that's okay. So you put the amount of work that you need to put that's appropriate for you. And don't let me, the teacher, say, no, you have to have 5 steps, all color-coded. No, because your mind might not work that way. And that's okay. That doesn't mean you're broken. That just means that you are thinking at a different type of area, which is fine. It always drove me nuts. No, you didn't show this one last step. So you missed 1 point. But really? That's kind of goofy. Okay? I'm pretty sure most of you haven't had a math teacher tell you that. Correct. You showed the amount of work that you would need to show. Now, the only place that you would lose points on this problem is if I said, write an equation, and you didn't. You just gave me the answer. So that might be the only spot that you would lose work. But not showing all the work all the way down, if you don't need to do it, that's fine. You're not offending me. I'm not crying myself to sleep about that. It might be other reasons, but, won't do that. Hey, can I move on to number 2? This one says, it took Matt twice as long to do his homework as his brother John. Okay, if John got his homework done in 2 hours, how long did it take Matt? So Matt took longer. Agreed? So Matt, whatever the time it took Matt to do his homework, and you got John here. John got his homework done in 2 hours. I'm pretty sure we can all see that the answer is going to be 4. Agreed? Ooh, hang on. So I'm pretty sure we could say this is going to be 4 hours, but let's say I said you have to make an equation. How are we going to decipher John in 2 hours and Matt is 4 hours? Yeah.
Well, since you already know, you're not really talking about John in the equation. You're just talking about the 2, so you can just do 2 times 2 because it's twice as long, and then that equals the amount of hours.
So
Just do 2.
so basically you said Matt is John times 2
Yeah.
kind of thing? And we can start subbing things in. We know that John only took 2 hours, so m equals 2 times 2. And again, I'm showing more work. I mean, we got to this with just logical thinking, which is fine. Okay? How are we doing on this? Was that it? There was no more? That was as far as we could go? All right, so friends, those of you that need to go get a book, why don't you grab your $5, your ID, and run down there. It's an orange cover, number 536. So if you need to take a picture of it, you can. But we're going to do pages 11 and 12 for tomorrow.
Where is it at?
It's in the IC building, so go up these stairs, go all the way down the hallway, go out of the building, go into the next building, and keep walking straight in that building, and you'll get there. And I'm going to stop recording unless there's anything else.